time times f, where time is time measured in years. You can rewrite this as 1 plus r over f raised to the power f raised to the power t. All right? Because for exponents, uh, x to the power a to the power b is the same thing as x to the power a times b. Now, let's f approach infinity. Remember, that's when continuous compounding happens. Basically, I'm compounding every single millisecond and even finer than that. So, limit of 1 plus r over f raised to the power f t as f goes to infinity is actually e to the power rt. Oh, this will be minus t. I'm sorry. So that is the present value factor for continuously compounded rates. And this comes from the fact that for x, that's a fancy way of saying x is not infinite, it's finite. Limit as a goes to infinity, 1 plus x over a raised to the power a is a to the x. In fact, that's one of the ways we can approximate e. Do you guys know the history about e? That's a weird number. It's an irrational number. The first four digits are 2.718. And if you use that as a base for a logarithm, it's called natural logarithm. But it sounds like there's nothing natural about that number. You know, it's not 1, it's not 2, it's not even a fraction, because you cannot write that number as a fraction. That's what irrational means. It cannot be written as a ratio. It's not irrational in the sense that it's crazy, but it's irrational in the sense that it cannot be written as a ratio. Square root of any prime number, for example, are irrational. Do you know where that number comes? It comes from, it is the answer to the following question. Think of a function f of x, okay, an arbitrary function, such that f of 0 is 1, and derivative of f of x is also f of x at all values. This is called a differential equation with a boundary condition. If you solve that differential equation, f of x has to be e to the x. E is 2.718. I mean, the way you kind of do it, have you guys ever heard of something called Maclaurin series for a function? Basically, Maclaurin series, you can always write f of x at some x0, okay, as I equals 0 to infinity. I'm going to call this fi at x0, fi at 0, I'm sorry. Well, f superscript I means it's ith derivative. So if it's 2, you differentiate the first derivative and so on. Times x0 raised to the power I divided by I factorial. Well, factorial is product of all the integers up to that number. For example, 3 factorial is 6. 1 times 2 times 3, 4 factorial is 24, and so on. So if you apply to this, by definition, all numbers, all derivatives have to be f of x. And when they're evaluated at 0, they should all be 1. So this basically says if I evaluate that at 0, it should be sum of, let me see, something like that. See? Oh, no. Oh, f of x. I'm sorry. Yeah, something like that. When you evaluate that x equals 1, you actually, that series converges to the number e. That's what's natural about it. It's not anything natural. And you have to thank, of course, a Swiss German mathematician called Euler for that. He came up with that number. But it comes in very handy in a lot of stuff, especially in complex analysis. You cannot do without it. You know, a lot of trigonometric stuff you may have seen in high school, most of those identities actually come from the so-called polar coordinates representation of angles, and that involves that E number. All right, let's. Where are you? What happened here? Well, I wanted to Visual Basic. So we know how to calculate present value of $1 and continuous compounding. This little function figures out exactly how much time you have left. Why can't I see? Why don't you guys see my screen? Let me stop sharing. What did I do here? If we lose connection, something is weird. Anyway, let me switch to my laptop view since there's nobody on. Okay. DKUIT have taken a blood oath to make my life miserable. They are not my favorite kind of people. I once told one of them after they got me so mad that you guys have no right to call yourselves information technology. And the poor guy was naive enough to ask me why. And I told him, you have neither information nor technology. But then again, the law of economics works. If they were any better, they would probably be working for Google instead of EKUIT. Before we calculated time to expiration as number of days from today to the date, so we said date minus today. But I'm gonna add the iClose number to the iDate, because the way iDate is constructed, it assumes it's 12:00 a.m. But I'm gonna add the iClose, so closing time on the date of expiration minus now. Now is a VBA function that calculates exact time or the system time. If you want to use that in worksheet, it's equals now two parentheses without an argument, just like today was. Now going back to my Black-Scholes euro, in addition to our standard arguments, the spot, the strike, date, volatility, interest rate, I also put in an optional argument called I yield. This is relevant when you're calculating options values for foreign currencies, because unlike a stock that doesn't pay a dividend, a foreign currency, if you don't do anything with it, earns something. If you have pounds, presumably you're not going to keep it under your pillow. If you got a £5 bill, you may. That's what they call a buck. A buck is a quid in England. You say $10, they say tenner. $5, fiver. I spent some time in London, so I know some of the terminology.